Ever watched a video and wondered, what happens if we stretch the frame? Like what if we add new scenery to the sides of a scene, but it all still feels real? That's the tricky challenge of video outpainting, extending a video's borders while keeping everything looking seamless. But here's the catch. Traditional methods often end up with blurry, weird results. So how do we fix that? Let's break it down. Video outpainting isn't just about adding pixels. It's about maintaining consistency across frames. Imagine a video of a person walking. If we stretch the frame to show more of the background, the person's movement and the environment need to still make sense. But existing techniques, which were designed for inpainting, filling in missing parts of a video, don't work well here. They focus on hiding flaws, not expanding the world. The problem? These models get confused when there's no existing data to base the new areas on. It's like trying to guess the next scene in a movie without any context. The result? Blurry, disconnected frames. So researchers behind this study asked, what if we retrain these models with a smarter approach? Their solution? A hierarchical discriminator, a kind of AI critic that evaluates both local details like textures and edges and global consistency. Does the whole scene still feel real? Here's how it works. The discriminator has two parts. The first checks the local quality, making sure the new pixels look sharp and match the existing ones. The second compares larger chunks of the video, ensuring the extended areas fit the overall story. It's like having two editors, one who polishes the fine print and another who checks if the whole book makes sense. They also created a special loss function, a recipe for the AI to follow. This function blends feedback from both the local and global checks, teaching the model to avoid blurriness and keep the video coherent. The results? Their method outperforms existing techniques, producing videos that feel natural even when stretched. Think of it as giving the AI a better set of tools to paint outside the lines, without smudging the picture. Now let's zoom out. Video inpainting, restoring missing parts of a video, has been a long-standing challenge. Traditional models like IN2OUT and ProPainter focus on filling gaps in static scenes, but they struggle with dynamic content. The key difference? Inpainting assumes missing regions are small and localized, while outpainting requires the AI to extrapolate entirely new content. To tackle this, researchers tested their method, called IN2OUT, against existing models like FuseFormer, M3DDM, and MOTIA. But here's a catch. These models only work with specific video resolutions, 240p, 144p, and 256p, respectively. To compare fairly, the team resized videos up and down, like stretching a photo to fit a frame. They evaluated their approach on two big-name datasets, YouTube VOS and DAVIS. Think of these as standard video test tracks used by scientists. For DAVIS, they focused on 50 clips at 480p, while YouTube VOS was resized to 240p for training and 360p for testing. Now, how did they measure success? Three key metrics. PSNR, peak signal-to-noise ratio. Higher numbers mean clearer, less noisy videos. SSIM, structural similarity, measures how similar the restored video looks to the original. VFID, video frame inception distance, compares videos perceptually like a quality score for how realistic they feel. The results? Their method smashed the competition. On YouTube VOS, it boosted PSNR by nearly 2 dB over existing models, like turning a grainy video into a crisp one. On DAVIS, it outperformed others in both clarity and realism. But it's not just about numbers. Visually, their method seamlessly extends scenes. Imagine a car driving off-screen. Other models might leave jagged edges or blurry gaps. IN2OUT, however, predicts where the car should be next, maintaining motion coherence and texture. Yet challenges remain. Static scenes, like a still landscape, still trip up the model. Sometimes it blurs details or misses objects entirely. This shows that while progress is rapid, video inpainting still has hurdles, especially when dealing with complex, unchanging backgrounds. What's next? The researchers hope their techniques will power better video editing tools, virtual reality, and even AI-driven storytelling. And who knows? Maybe one day, you'll be able to edit your vacation videos as easily as you edit photos. So next time you see a video that feels expanded but still seamless, you might be looking at the future of AI-powered creativity. Thanks for watching, stay curious, and let's keep exploring the magic of machine learning.